This. Yes. Now we are good. Oi, hey, LB, would you get those lights turned off? It's too bright. The lights, it's too bright. Yeah. When Boss and Lauren around, like. So today is the 21st. It is 1/21/25. So yeah, so I've got some stuff to learn today. So I think we should call this features of rational graphs. Maybe not the world's best, most well thought out title, but what we're tracking down today is, by the way, I don't know if this is good news or bad news, but for today's assignment, no graphing required. All we're doing today is we're going to find 5 features or characteristics for each rational function. And I will go through, as we do the first example, I'm going to show you in order the way we're going to find them. And I chose this order. The order could be negotiable, but since your assignment's going to be on a computer and the computer gives them to you in this order, I thought it would be polite to teach them to you in the same order. So anyways, there are 5 things we're going to look for. So let me put the first example up here and then we'll just talk our way through it. So for our first function, we have f of x equals 5x minus 15 over negative 2x squared plus 4x plus 6. Feel like everyone's gotten the memo, but I better ask again. What do we do first? That's right. You clearly got the memo. If you didn't know that, then I'm sorry. But the factoring, factor. We want to expose every part and piece that we possibly can in order to look for things that cancel holes. So having said that, the top is going to be pulled out by 5. So the top is going to be 5 times x minus 3. And then the bottom is going to be negative 2 times x squared minus 2x minus 3, right? But these ones are annoying because, like, if you're good at factoring, then you can probably do that step and the one we're about to do mentally. But it's kind of hard to keep track of factoring post GCF, like all in the noodle up here. So what does x squared minus 2x minus 3 factor down into? Right, x minus 3 and x plus 1. So the final factored version is this. This is as factored as this rational function expression could possibly be. So any questions on that? Okay. Does anything stand out? Right. So we're going to want to give those just a light cross out, kind of like this, as if to signify that they are going bye-bye. The 5 things, and again, I'm gonna pick this order. I better just look at Delta and just make sure that I'm doing the order correctly, because that would be really, really funny if I said that and then I didn't give them to you in the right order. Oh, so the whole is the last thing. So I'm glad I checked. So this is what your assignment's going to look like, just FYI. So we'll do hopefully one of these together, but you'll be asked for these 5 things. And notice that there's an option for there isn't one of these, and that's going to happen really quite commonly. So we're going to do horizontal, then vertical, then X, then Y, then whole in that order. So let's start with horizontal. So does this function have a horizontal asymptote? This is a good time for you to ask if you're not sure. This can't be something that after today is something we're not good at. There are 3 options, okay? There will be a horizontal asymptote essentially at 0. There'll be a horizontal asymptote at the ratio of the leading coefficients, or there won't be one. And that's not necessarily true for all rationals, because like that other assignment 26, we had some little stragglers at the end, those little silly pluses and minuses that made it move up and down. But for this assignment, every problem you see is just going to be a top and a bottom. So your three options are no horizontal, horizontal at 0, or horizontal at a specific location. So which one is it for this? It's at 0. Good. And the reason is, and you can add this into your notes in some clever way, is that look at the degrees of the top and the bottom. What is the degree of the top of the function? It is 5x to the power of 1. Therefore, the degree on top is 1. What is the degree on bottom? It is negative 2x to the 2th. Therefore, the degree of the bottom is 2. And you need this in your notes. I mean, hopefully we never have to talk about this after this one, but if the degree on the top is smaller than the degree on bottom, then you will always have a horizontal asymptote at y equals 0. Okay. In other words, the x-axis will be replaced essentially or copied over with a horizontal asymptote. I want to say this again, that the only time that's not going to be true, what I just said, is if after the rational part of it, if there were some little clinker number, like a little +4, then that would take that 0 and just shift it up 4, right? We saw that on the assignment, but you're not going to see it on this one. So clear on that? Okay. Next up in line is the vertical asymptote. And I've just started writing HA and VA. Like, I don't know if that's super too lazy, but I really don't even care. So there it is. Does this function have a vertical asymptote? Do you know where to find vertical asymptotes? I'm going to take your silence as a no. This is a really critical lesson for you to talk to me if you can, because if you don't, I'm going to assume that you need instruction. And I might be saying things that you're like, we already knew that. And then I'm going to say something like, well, I didn't know that because you were silent treatmenting me. We find vertical asymptotes where the bottom equals 0 and where it doesn't cancel out. Okay? So don't look at the original one anymore. Like this one isn't going to be of any use to us beyond this point. Okay, we want to look at the factor, the clean one. Do you see any numbers that would make the bottom equal 0? What about 3?
But that's all.
That's going to be a whole. Good. So that's important that I know that you know that 3 is not a vertical asymptote. Does it make the bottom equal 0? Yeah, but it cancels out with something just like it on top. So it doesn't count. It doesn't make a vertical brick wall. So there is one vertical asymptote and it occurs at x equals -1 because -1 would make the bottom of the fraction equal 0 and it's not removable. There's no one on top that says, hey, let's cancel each other out. It's stuck. Good so far? Okay, the next thing up in the order, and again, I'm just going to mimic the delta math order of things, is we need to find a new guy, the x-intercept. Can you describe to me what an x-intercept is? Like just in very general terms, what is it? It's it, where the graph goes through the x-axis. So if you think about it, if a graph is crossing through the x-axis, what's true at that point in time? So let me draw a graph real quick. So here, this will be the nicest graph you've ever seen in your whole life. If I made you a little sketch of a graph and went like this, and then I went, well, that's not a very good graph. Hold on, I need to fix that. My horizontal asymptote got blown up there. Oh, me likey that much more. Do you guys all see the x-intercept? I don't mean to be rude and like insult you, but you can see it, right? It is quite literally the point where the graph crosses the x-axis. I'm going to put a yellow circle around it for you. Everybody see it? Other than snarky comical answers like it's yellow and it's a circle, can you tell me something mathematically accurate about the point that I circled? Huh? I don't care if it's negative. It could have been positive. That's not relevant. I mean, I appreciate the input, but tell me something else about it. Could you tell me the coordinates of the point that I circled? Okay, good. You cannot tell me the coordinates of the point that I circled, but you can tell me one of them, and you can tell me definitively that the y coordinate of that yellow point is 0. You don't need a math degree or any sort of proof to tell someone that the coordinates of that point right there that I circled are something, comma, 0, correct? Something. But the y, we talked about this back in Algebra 1, that if you want to know the x-intercept of an equation, you simply make y equals 0, correct? So what I want to think about when I'm finding an x-intercept is how can I make the function's value, the y value equal 0? If I gave you a fraction and I said make that fraction equal 0, what would you do? Nope. Here, I'll give you a fraction. I'll give you the easiest fraction I can think of. Like here, x plus 2 over 5. If I said to you, make that equal 0, what would you do?
Plug in.
What would you do? How does a fraction equal 0? Someone give me a fraction right now that would equal 0 if I simplified it. Go. Can I go first? 0 over 3. I did it. Because isn't 0 over 3 0? Give me another one.
0 over 5.
0 over 5. How about 0 over -9? Would that work?
Yeah.
So let me ask you my question again. How do you make a fraction equal 0? You make the top equal 0. The bottom is of no concern to me. If I can make the top equal 0, then I've made the overall fraction equal 0. I have therefore made the entire function's value equal 0. I have therefore found where the graph crosses the x-axis. So for your notes, when you get to the part that says find the x-intercept, your notes should say make the top equal 0. Make the top equal 0. Make the top equal 0. Got it? Good.
Was I wrong when I said make x equal -2?
No, that's right. I just didn't hear you. Does everyone agree, though? Are we okay to move on if we say that if we want a fraction to equal 0, we have to make the top equal 0, right? Okay, so let's go back to our function that's up on the board. This is going to be one of a couple of potential sticking points, but I'm always surprised. Sometimes young people make hard things easy and easy things hard. I never know. What number could you put in place of the top of that fraction to make it equal 0? So here's my inclination right now. My inclination is to say that the x-intercept, and you can write this if you want to, but I just want you to know that we're going to cross it off in just a second. My inclination is to say I'm just following orders. If I make the top of that fraction equal 0, I can do it when x equals 3, correct? If you put 3 up into the parentheses up here where I'm pointing with this arrow, if you put 3 up there, 3 minus 3 is 0, and 5 times 0 is 0. So there should be an x-intercept at the point 3, 0, right? Can you see maybe what's coming down the pike, like what's going to cause a contradiction here in a couple of minutes? Let's come back to this. I think you might be saying a good thing, but I'm going to come back in just a second. Let's move on to the y-intercept. By the way, I'm going to put a little arrow to this and say that's not true. But I want us to get rid of it in due time when you understand why we're getting rid of it, okay? The math tells us that there should be an x-intercept when x equals 3. Something else is going to kick it out. Something's going to kick it to the curb here in a minute. Let's go find the y-intercept. So what is true at a y-intercept? Again, I'll play the little game with you down here. If I circle the y-intercept, you can literally see it. It's in a green circle. What's true about that point?
X.
Right. So at a y-intercept, I have to make x equal 0. So if you go back to the function and you turn all of the x's into zeros, and by the way, I experimented just so you know, it doesn't matter if you put 0 into this function. Is there a better version of this function, by the way? Do you know what I'm getting at? Would there be a better way to rewrite the green box? That's it. So the functions are equivalent if we say 5 over -2 times x plus 1, because all I did is I took out the thing. I just reduced the fraction effectively. I took out the x minus 3's. So what I wanted to say is this: if you want to find the y-intercept, you can put it in the pre-reduction fraction, or you can put it in the post-reduction fraction, and you'll get the same answer. I would say that 100 people out of 100, barring maybe like crack smokers and people with some serious issues, would choose the reduced one, right? It's a little easier to work with. So we're going to take 0 and we're going to put it right where this purple arrow is pointing, and then we're just going to do a little bit of kitty math. Easy math. What's 0 plus 1? What's negative 2 times 1? And the answer comes out to be 5 over negative 2. So we can now say that there is a y-intercept at the point 0, negative 5 halves. And you can call that negative 2.5. You could call it negative 2.5, or you could just call it negative 5 halves. Finally, that leads us to the fifth, and the fifth one is to find holes. And so let's talk about holes. Do you guys remember where we find holes? Where something can cancel, right? And so it's kind of like we basically say to ourselves, the mission to find a hole and to find a vertical asymptote start out identically. If Cooper's looking for a hole and Blair's looking for a vertical asymptote, they both start their mission the same. They both look at the bottom of the fraction and say, how can I make you 0? Right? But we veer off course. They veer off course from one another if they find something that can cancel. So when we first set out on this problem, initially we looked at the bottom and said, well, x could be 3 and x could be negative 1. But the x minus 3 cancels, and therefore that is the one that is a hole. So there is a hole at 3, comma, blank. And this, Bryn, yes, is the part of the lesson where we now go and we try to figure out how to figure out the y coordinate of the hole. To just say that there's a hole at x equals 3 isn't really good enough. I want to know a y value so I can actually put the hole on the graph where it belongs. Bryn, you caught this yesterday, I think. Was anyone else catching it? Do you guys know how to find the y value of a hole?
You just plug it in, right,
Where?
on the bottom.
That's not what I meant. Make all x's equal 3, but here's the kicker. Do not use this one. Got it? Sorry for the vandalism, but I don't really need that anymore. Don't use the OG, because if you put 3 in there, you're going to get 0 over 0, which is undefined. I mean, that's why it's a hole in the first place, right? But the point is, don't use that. Put 3, your x hole value, into the function after it's been simplified. So you see where the purple arrow is pointing over there? That's where you should put the bad guy, 3. That's how you find your holes. Okay, so you plug your bad x value into the function post-reduction. And again, as always, it just comes down to little kitty math, which you shouldn't struggle with at this point. If you put a little 3 in there, what's 3 plus 1? And what's negative 2 times 4? Negative 8, which if we reduce 5 over negative 8 properly, it comes out to just negative 5/8. So we can now say that there's a hole at 3, negative 5/8. That completes this problem. Again, no need to graph anything today. You'll just be going through and putting information into boxes. Did that feel okay?
What about the next one?
Oh, I wanted to go back and talk about the x-intercept, clearly. Correct. And that's what I was going to get at. I thank you for stopping your dumb teacher. I was just about to hastily move on. Why is there not an x-intercept?
Because there's a hole.
Because the hole is there. Good. So what happens is you essentially say to yourself, there can't be an x-intercept at 3, 0 because there's a hole already at the x value of 3. So nothing else can be defined at an x value of 3. So when it comes to x-intercept, we would choose none. The only number that would have made an x-intercept effectively got canceled out. That's a nice, easy way to think about it. So if a number wants to make you an x-intercept, but it gets canceled out, then it's no longer an x-intercept. Holes and x-intercepts can't simultaneously exist. Thank you for reminding me of that. Now, is that okay? Do you feel good about that? Let's go again. I can't tell from the body language how you're feeling, but let's try another one. And then after this, you can give me like a thumbs up, thumbs down rating. So this one is f of x equals. And if we just want to do this all hour today, I'm fine. And then tomorrow can just be a big fatty, like maybe tomorrow and Thursday are big chonker work days. I don't even care. Sorry to ask this again, but what do we do first? We factor the living daylights out of this. And again, you can test yourself. The top, we obviously have to pull out a 2. Can you picture what it would say after you pull out a 2? And then subsequently, can you factor it in your head? It's not simple. Nice job. It winds up being x squared plus 4x plus 4, which factors down into x plus 2 times x plus 2. Very good. So this is the clean version of the function. It's not the reduced version, but it's the clean factored version. Good, good. Okay. So let's run through and real quick, let's give it a quick cleanup. Let's go ahead and take these since we can. One of these x plus 2's and the x plus 2 on bottom can go away. What's that telling us later on down the line? There's going to be a hole at x equals -2. And then to figure out the y value that goes with it, we'll just plug it in the post-reduction phase. So what is the cleaned up version of this function? What would it be? Gorgeous. Yep, and you don't even need the over 1. Nope, you're fine just like that. You might be surprised to know that if you actually graph this, I believe it just comes out as a straight line, which is interesting that a rational function can look like that. But when it simplifies down to a linear, well, you get what you get, I guess, huh? So let's go through now in order and let's do all 5 components. Let's begin with the HA. Does this graph have a horizontal asymptote? It does not. And this is now scenario number 2. Scenario number 1 was the first problem. When the degree on top is smaller than the degree on bottom, in other words, less x's up than down, there's always going to be one at 0. If you've got more xness on top than on bottom, and we can talk about that. What's the degree on top?
2.
What's the degree on bottom?
1.
Right. And if, 2's more than 1, when your degree on top is bigger than your degree on bottom, there is no horizontal asymptote. Okay. That is a very, very distinct possibility. Let's talk vertical asymptote. Where can we make the bottom equal 0? Nope. Nope. I know I'm just kind of messing with you. Yes, I get it, -2, but what did we do with -2? We canceled it. So it should not be in our discussion about a vertical asymptote. There isn't one. Good. So we find ourselves here in a situation with no horizontal asymptote because of the degrees, no vertical asymptote because there's nothing left on the bottom to make it ever equal 0, which presses us in now to the intercepts. So let's head into the intercepts. So let's start with x-intercept. What do we do when we want to find an x-intercept? Be more specific. Don't say it. Yeah, that pronoun it can be dangerous. Let's make the top of the fraction equal 0, which comically in this case is not really even a fraction anymore, right? It's just a rational function. I mean, it's a linear function is what it looks like now. So to find an x-intercept, you can take your simplified version of the function, which is over here. I'm circling it for you. And just essentially, when it comes like that, just make the whole thing equal 0. What would make that equal 0? If x were -2. So again, I'm inclined to say that there's an x-intercept at -2, 0. But there isn't one y because there's a hole. And again, I was cautious last time to jump ahead to that, but having done another example like this, you now would catch yourself and say, no, that's not actually an x-intercept. I'm getting an overlap there. The x that would make the x-intercept is the same as the x that's making the hole. The hole wins 10 times out of 10. So for x-intercept, there is none. Got it? How about, and I think that one I'm going to go back and revisit. I think I'm going to disagree with myself on that one. You should be too. Anyways, let's do y-intercept real quick.
Can there be one because there's no bottom and simplify?
There will be one, yes. And so I need to go back and correct that, but I don't want to talk about it right this second. So let's head on to the y-intercept. What's true? What do we do at a y-intercept? Not the x in the bottom. We just make all the, yeah, just make all the x's equal 0. So if you want a y-intercept, just make all the x's equal 0. So if you put 0 right here, what do you get? You get 4. And actually, I think I'm going to stick with my x-intercept. I think I like it. I don't think I'm going to talk myself out of that one. And I'll tell you why here in a sec. But is there a hole?
Yeah.
There is, and that's why I'm okay with the x-intercept going away. So there's a hole at -2 because remember the x plus 2 canceled out. And I want to ask you again, how do we find the y coordinate that goes with the hole?
You plug in two all your
Do you
All
plug in
negative
force.
two.
plug in -2 to all the x's? And remember, just plug it in post-reduction. Don't plug it in pre-cancel or you'll get 0/0. That's, of course, it should be like a no-brainer. So we're going to plug -2 into the post-reduced fraction, which is where the purple arrow is pointing. And if you put -2 in there, what's -2 plus 2? 0. What's 2 times 0? 0. So there's a hole at -2, 0. And that's why there is no x-intercept. So I'm sticking with what I said. Can't have a hole and an x-intercept at the same place. Still feeling okay? Okay. I want to do at least one more. And then if you feel like you want more, we can. I definitely want to do the last one with you too. And we could do notes all hour, but I just want to make sure you're comfy. This is a tough assignment. I found myself when I was going through it having to use a lot of like scratch paper and brain power. So maybe you'll find it to be pleasant and simple. I don't know. Anyway, so our function this time is f of x equals x squared plus 7x plus 12 over 2x squared plus 2x minus 24. Let's see how powerful our factoring skills are. The top should be light work. What does the top become?
Plus 4 times x plus 2.
Yes. You could take the world's worst factorer and have them factor the top, and they're not going to struggle with that one. The bottom, again, it just depends on how much you want to tackle mentally. Can you pull the 2 and parenthesis factor? I mean, for what it's worth, I believe in you. If you pull the 2, it'll say x squared plus 1x minus 12. So let's pull the 2. Can you tell me what that's going to equal?
You need a positive 4 and negative 2.
Correct. And if I'm making you uncomfortable, then you are a prime candidate for someone who should do that factoring in 2 steps. You should pull the 2 out first and let yourself see the x squared plus 1x minus 12 so that you can more comfortably transition over into the fully factored one. That's going to be different for each of us, the speed at which we want to do that. Got it? So there it is. Let's go ahead and do a little cleanup work on this. We're going to go ahead and give our x plus 4s a cross out, leaving us with a final function that looks like this, x plus 3 over 2 times the quantity of x minus 3, and the journey begins. So let's start with the horizontal asymptote. Does this graph have a horizontal asymptote? So we have seen the reason I picked this example very specifically is because in our first example, we saw one that had a horizontal at 0 for degree reasons. Second example, we saw one that doesn't have a horizontal for degree reasons. This one has one at a very specific location. Where is it? At 1/2. Good. When the degrees are the same on the top and the bottom, which they are, x to the 2 and x to the 2, like that's a tie, right? No one's bigger than anyone else. That's when we defer to the numbers in front. And in front of the top is a 1, in front of the bottom is a 2. That makes a ratio of 1/2. So we say there's a horizontal asymptote at y equals 1/2. Okay. Next up, let's hunt for the vertical asymptote. Some functions eventually are going to have, not probably this week, but eventually we're going to see multiple vertical asymptotes, which creates lots of little graphy regions. Okay, but for now, I think we're just ever going to find one. So does this graph have a vertical asymptote? Where?
Yeah.
Correct. I'm getting the hang of it now. When x equals 3, that makes the bottom equal 0, and that x minus 3 never gets canceled out. So he's a keeper. He's a vertical asymptote. Next up is the x-intercept.
We just need to copy.
That's it. Now we're cooking. We're going to make the top equal 0. So you want an x-intercept, you need the whole function to equal 0. Therefore, you need the top of the function to equal 0. It's like connecting the dots. And if you make the top, it's over here in yellow, equals 0, where does that happen at? At -3. So we can say that the x-intercept is at the point -3, 0. Make sure you do not name your intercepts as just numbers. Name them as ordered pairs. That'll help you get through the assignment. Let's head over to the y-intercept. What do we do to find a y-intercept?
Plug in.
That's right. Good job. You're getting this now. So to find a y-intercept, we're going to go and change all of our x's into zeros. So where these two purple arrows are pointing, that should become a 0. And that should become a 0. And then all you have to do is math, which, should go pretty well. On the top, what's 0 plus 3? Nice. And on the bottom, what's 0 minus 3? And what's 2 times -3? -6. So that reduces or simplifies to -1/2. So we can say that there's a y-intercept at the point 0, -1/2. And then finally, hole. Is there a hole? Yeah, because we canceled something out. There's going to be a hole. If we cancel something with a variable in it, there's going to be a hole. And we know the x-coordinate of the hole is what? -4. But we learned today, and some of us yesterday, how to find the y-coordinate that goes with a hole. What do we do? Yes, make your x's equal -4, but specifically where? Post reduction. Good. So make sure you go to your quote unquote like final function form and change the x's there to -4. A lot of basic math, right? Math, the kind of math that you don't need a calculator for. It's just a lot of like really ugly sort of fraction-y reducing crap. So if you take -4s now and put them where the purple arrows are on top, what's -4 plus 3? -1. And on the bottom, what's -4 minus 3? And what's 2 times -7? -14. So that reduces to 1/14. And when you do get around to graphing these, which again, we're not going to do today, you'll see that it'll make sense why these things are where they are. They fit real nice with the curves. But there's a hole at -4, 1/14, which is almost like imperceptibly above the x-axis, just slightly above 0.
How would you accurately graph that?
What I usually do with my holes is I go back and they're the last things that I graph. And so I let the curve just sort of naturally, kind of like you were doing on assignment 26, just use your asymptotes and what you know and find some points, connect the dots, and then I go back with an eraser and I erase and put the holes where they need to be. And you'll find that they fit real nice. Like the curve will just sort of say, hey, I got a spot for the hole. You know what I mean? The hole and the x-intercept are not in the same place, and so this is fine. The x-intercept can stay. Where we get concerned is if we make a claim that there's an x-intercept, but then we also claim that like if we had claimed that there was a hole at like -3, 2, then the x-intercept has to die. They can't have the same vertical alignment. You guys got it? So where do you want to go with our time? Do you want to do another example or do you want to go try a delta math? It's up to you. Do you want to try it yourself? Okay, I've got 4 more examples in the queue. I don't think we need them right now, but I'm not going to throw away this note card. So your assignment is on delta. It's assignment 27. We've got about 9 minutes. So let's see how you do. You're going to need scratch paper. That's not a question or an option or a challenge. You need paper. You need to factor and watch yourself canceling stuff out and doing basic math and all that. If you want to use a whiteboard, you can. If that's your thing.